Today's Synergist Town Hall webinar, Get the Answers to Your Top FRCP Questions. My name is Ed Rakowski. I'm the Editor-in-Chief of the Synergist, magazine of the American Industrial Hygiene Association. I'd like to thank all of our attendees for participating, and especially Bulwark for sponsoring today's webinar. Today's presentation was built directly from questions submitted by users of flame-resistant and chemical protective clothing. This webinar will be presented in a question and answer format, but we're going to reserve some time at the end of the hour for any new questions our audience may have. Our presenter today is Mark Sainer, who is the FRCP Technical Services Manager for Bulwark Protection. He previously held a similar position with the Workrite Uniform Company. He brings more than 35 years of experience in the fire and safety industries to his work, including 25 years in technical support, safety standards, and product development for the Akron Brass Manufacturing Company. You can contact Mark for information on topics related to FR hazards, product performance, and industry standards. Now I'll turn the presentation over to Mark.
Thank you, Ed. Appreciate the introduction, and I want to thank and welcome everybody to today's webinar. As Ed said, there have been a number of questions that have come up since previous webinars, and we're going to try and talk to those and address those so that everybody has a better understanding on what this is all about. But as a kind of just an intro, just want to make sure that everybody's aware that the customers of ours are the ones solely responsible for conducting their own hazard risk assessments to identify which hazards they have in their particular work environments. And they're also responsible for selecting the right garments that meet their needs for those particular protection needs to take care of their hazards and try and protect their people. So with that said, why don't we go ahead and get started? One other little bit of intro I want to do is, we've got a lot of questions that have come in on these lab coats, and so I'm going to do my best to try and answer them for you. If I don't answer it completely or you have other questions, as Ed said, please drop those into the chat and we can try and address those at the end question and answer period. For this particular presentation, I just wanted to define a couple of things and make sure we're all on the same page. FRCP stands for flame resistant chemical protective. And by flame resistant, we're talking about fabrics that will self-extinguish, they don't melt, drip, or add to the injury of the wearer. And in terms of chemical protection, in this particular case, we're talking about protection where it repels small amounts of inadvertent chemical splash at atmospheric pressure. So not every splash, not under pressure, not every chemical, but that inadvertent, accidental, small amount of splash at atmospheric pressure. So that's where this all starts off. So let's get into some of the questions and the answers that I have to try and address those. The first question that came up was regarding penetration, permeation, repellency of liquid chemicals. What is that all about, and how does that fit in, and what's the difference between them? So depending on what your needs are will depend on whether you want something that has penetration or permeation or repellency properties. So it depends on what you're being exposed to and the level of protection that you need for your particular wearers. So that's why you need to do your hazard assessment. That's why it's needed. And the assessment, it'll dictate to you whether you need which level of protection. So when we define those three different types of protection, penetrations when liquid passes through the basic pores, imperfections in the material, closures, seams, interfaces with some amount of pressure. That's what's defined as penetration. Permeation, on the other hand, that's when the liquid actually moves through the material. It's absorbed into the surface, it diffuses through the fibers of the fabric, and then it desorbs on the opposite side over time. So that's the difference between penetration and permeation. And then repellency is simply the ability to resist wetting without pressure. So when you put a drop of the liquid on it, it doesn't immediately wet and wick into the fabric. So that kind of sets the stage for the differences. But it all comes down to what does your hazard assessment need? What is the chemical, or what are the chemicals that you're being exposed to? That'll make a difference on whether you need something that has pure permeation protection, which is more like a barrier suit, or whether you need simply penetration or repellency properties for your particular workers. The next question talks about, does the type of PPE worn and how it's tested matter if it's an irritant, a sensitizer, or a carcinogen? And the answer to that question is yes. The more severe, potentially damaging the exposure, the more protection you're going to need. An example I have here is if the exposure is potentially life-threatening, such as a carcinogen, and it can have a long-term life-threatening effect, then you need something non-permeable PPE. That's what you need to at least consider. If you're basically just looking at skin sensitizers, they can also cause some serious long-term allergic reactions, and that may also justify having a non-permeable PPE. Irritant effects typically go away, once the exposure is gone, so, that takes it a little different level. So a thorough hazard assessment is required, and you need to evaluate not only the lab coats, which we're talking about in our sense, but also hand protection, face protection, breathing, interfaces between the different pieces of PPE. All those come into play, but the difference between irritants, sensitizers, carcinogen, it does make a difference. So depending on what your level of hazard, how damaging it is, how dangerous it is, you need to maybe scale up in the protection level that you provide. So how do you select a chemical protected garment that can be worn over flame resistant clothing? Well, any chemical protected garment can be worn over FR clothing, but if you have an FR exposure, it needs also to be FR. If there's an application where FR is needed, the outer layer, that's the rule, the outer layer needs to be FR. You can't wear a non-FR over top of an FR. So in this case, if you have both the chemical splash and the thermal exposure, then you're going to need a garment that's going to protect from both. You need to have both FR and chemical. But remember, the outer layer always needs to be FR. If you have an FR exposure, thermal exposure where you could have clothing ignition, the outer layer needs to be FR. And obviously, if you're going to have a chemical, then it also needs to protect against the chemical splash. So outer layer always needs to be FR. Important thing to remember. So which FR standards right one to look for when evaluating lab coats for FR exposures? Well, it depends on the FR exposure the wearer may potentially be exposed to. So, for example, if the thermal exposure is a flash fire, which is most common, you've got flammable chemicals, you've got some ignition sources, whether it be Bunsen burners or other hot plates or things that could ignite a flammable vapor. That garment then needs to meet NFPA 2112. That's the FR standard to look for when you're looking for flash-type fire exposures. If there could also be an arc flash, which is not overly common in laboratories, but could be, or if it's in something outside of a laboratory, if there's an arc flash exposure, then the garment needs to meet ASTM F1506. This gives it an arc rating, and you need to make sure the arc rating meets your exposure. So you have to have an arc hazard analysis done, how many calories of incident energy is potential in an arc flash, and then you need to match your clothing to be equal to or greater than that particular incident energy exposure. So it depends. 2112 for flash fire, ASTM 1506 for arc flash. Those are the two key standards in the thermal industry. Next question, are there cleaning recommendations for FR garments? Yeah, there are, but it's pretty simple. FR garments, typically they can be just washed like regular work clothes. Common laundry detergents. Most people like to use liquid laundry detergents, but just common detergents can be used to clean it. Things like chlorine bleach, peroxide, softeners, those are no-nos. Shouldn't be using those. Those can have an impact on the flame-resistant properties. They can mask them. They can add layers on top of them, which can inhibit their ability to work right. So Each garment's going to have laundry instructions, and if they're followed properly, there should be no issues. And all the Bulwark garments, they have used fabric that their flame-resistant properties are guaranteed for the life of the garment, assuming you follow the laundry instructions. So it's pretty straightforward. Simple laundering, just like you do regular clothes. You should separate them. You don't want to wash it with your regular clothes. Don't use the additives, and everything should be fine. Pretty straightforward. So, question, can the dual hazard FRCP garments be laundered? Kind of goes back to the other one, although that was specific to FR. And if so, is there a limitation on the number of launderings? The simple answer to that is yes. FRCP garments can be laundered just like FR garments, but Milliken, that makes the fabric, has established a limit recommendation to 50 industrial launderings for the FRCP fabric. And we're talking industrial launderings, which is a little more harsh than your common home laundering situation. The FRCP, it'll continue to repel some of the chemicals past that 50 mark, but it does start to lose some of its ability to repel some of the other ones. So it's kind of hit and miss. And it's not you hit 51 and it drops off and has no repellency properties. It's a gradual reduction in its ability to repel. It goes from, high level repellency to, a little bit less and less over time. There have been some tests done and, over time, depending on how you launder them, some chemicals repel up to, 80 or 100. Typical lab coats, what we've found when we've talked to people in labs, lab safety people, they say they don't wash them very often. They wear them, hang up on the back of the door, and, so 50 can be quite a long time. We've had people say, we wash them 3 or 4 times a year, which, even if it's 5 times a year, you're talking 10 years worth of use. So 50 is a pretty long number. And that's, again, industrial laundering. So this is one that has come up a number of times, and it talks about powdered dust as a hazardous chemical. And when we're talking chemical repellency, we're talking about liquid, aqueous solutions. So, we wear their coveralls. They wear them for chemical to prevent that dust, to prevent it from skin contact. They also have occasional arc flash exposures. Would a basic FR coverall work for both of these hazards? A common standard woven FR coverall with the right arc rating for their exposure would be okay. It's not designed to protect from dust particulates, though. It works fine for the thermal, the arc protection, and or, a flash fire protection, but it's really not designed for dust particulates. All these fabrics, I shouldn't say all of them, but most of the FR fabrics, the ones that are daily wear that you're wearing, coveralls, pants, shirts, they're air permeable. They have openings. They can allow dust to get through the gaps between the different yarns of the woven fabric. So, to truly protect it from, particular exposure, you need a garment that's designed for that. And if it's arc flash that you're needing to protect, then it also has to have an arc rating. It has to be both FR and arc rating. If the arc rating doesn't have to be high enough, which could be the case, then you can get into layering, and the underlayers could have an added effect to boost up that arc rating to a number that's sufficient for whatever your incident energy exposure is. The thermal exposure environment, remember, again, outer layer must be FR. A garment that's particular protection, it may not be FR. That isn't particularly a common thing. So, a secondary FR particular garment may be an option. So, it's a tough one. Standard FR, including the lab coats, are not designed for particular protection. Just because it's CP that repels liquids doesn't mean it's going to repel particulate. It's still got openings. It's still a woven fabric. So particulate's kind of a different animal. Are there FR garments suitable for clean room applications? This comes up all the time. And clean rooms get a bit tricky. Bulwark garments are generally woven or knit fabrics, which will produce some amount of lint. And so they're not designed for clean room applications. There are garments that will do that. There's some that are made with a Nomex filament yarn, which doesn't shed the lint like a regular woven spun yarn type fabric fibers would have, or yarns would have. And that's designed to be used in clean room environments. And that also fills the need to be FR because it's a Nomex. But standard FR garments are not designed for clean room. Even the lab coats, it's still a spun yarn, woven fabrics. There's going to be some lint that's going to come off. So, it's really not suited for that kind of application. You can see I put a link down here on the bottom that takes you to a DuPont site that has some information about their clean room application. So that would be a good place to chase that down. It's not something that Bulwark carries or Bulwark is involved with in terms of clean room. Do FR fabrics have an issue with skin exposure because of the FR chemicals? Well, FR chemistry has been extensively tested for the skin irritation, contact, sensitivity, toxicology. FR chemistry has been around a long time, and there's been lots of testing done. And as far as I know, all these tests have shown that there's no particular irritation or contact sensitivity caused by those flame retardant chemicals that's used in the fibers or the fabric. Now, could some individual have a particular allergic reaction or high sensitivity to them? Anything's possible, but most of the times we found out it's not the chemistry that's the problem. It's the fabric, the way the yarns are made, the way the fabric's woven that is more of a problem. But as I said, there's been lots of testing over the years, and there has not been any particular toxicology reports or skin contact irritation reports or anything has shown that the chemistry in the FR has been a problem. So why would a reusable lab coat be any better than my disposable one? A couple of things. The main reason is the reusable lab coat, like the FRCP coat, is preferable in avoiding the human decision point. So what I mean by that is if you have a reusable lab coat that you just put on as you need, that means there's a decision point. That wearer has to decide, I need to put this on now. I need to put this chemical repellent lab coat on. Gee, where did I put it? Is it around here? I got to go to another room to find it. Whatever the case may be, and they just might not do it. It's only put on, the disposable's only put on when it's needed, and so that gives you that decision point. Gives them an opportunity to either forget to do it, or they might choose not to do it. They might say, gee, I've done this experiment 100 times. I've never had a problem, and I'm not going to bother this time. I don't know where I put that crazy disposable one. I'm not going to bother. When you have the FRCP one, on the other hand, it's worn as daily wear, all day, every day. Eliminate that decision point that the wearer has to make. It's still breathable. It's still comfortable to the touch, just like the standard lab coat. But you don't need to go find that repellent disposable version. Takes away that decision point, because we know over history, if you give the person a decision to make, there's chances they're going to make a wrong decision. As I said, they've done this experiment 100 times. Never had a problem. Not going to have a problem this time, and that's when a problem happens. So having it on all day, every day, reusable, keep laundering them. Not to mention the fact that you don't have to keep buying the disposables. You wear it once, you throw it away. You can go through those in a hurry. So there's a cost factor that could be involved as well. So this question, our lab doesn't work with flammable chemicals, so is an FR lab coat really necessary? Well, if there's no flammables in there, it may not be necessary. But are there open flames? you have a Bunsen burner? Are there other thermal devices that could ignite the coat sleeve? If that's the case, it might be a good idea. I had a lab manager tell me she had this experience with a worker reaching across the work table, exposed her sleeve to an open flame, and actually caught the coat on fire. They were able to extinguish it quickly, without injury, but, it could have gotten worse. So even if you don't have flammables, if you have open flames or other potential fabric ignition sources, you might want to consider FR. They last a long time. They cost a little more, granted, but, what's the cost of catching somebody on fire at work? So if you don't have flammables, maybe you don't need it, but make sure you're not working with open flames and other potential thermal devices that could ignite the fabric. Something to keep in mind. That's part of your hazard analysis, part of your risk assessment. So is there a solution for a chemical splash coat for labs without an ignition source? Similar kind of question as the previous one. And the answer to that is actually yes. Bulwark makes a non-FR lab coat that has all the same chemical repellencies as the FRCP. And it's got the same comfort property, but it's not FR. So there is one, we do make one, has the same chemical splash repellency properties, but it's not FR. And one of the big things that is nice, it is easily recognized as different from the FRCP because it's white, not royal blue. And the labeling says CP, not FRCP. So, our research has shown that, most labs have some kind of liquid chemicals, acids, corrosives, polar organic solvents, a number of chemicals, liquid, aqueous solutions that could cause skin injury. So, you want to be sure there is no ignition hazard, just like I said on the previous slide. And so if you need protection from these chemistries, then, that might be an option for you. I did put a note at the end here also, if you need protection from non-polar organic solvents, you might need a secondary permeable FR alternative because the FRCP, it protects from lots of things, acids, corrosives, oxidizers, polar organic solvents, but it really doesn't repel non-polar solvents. So that's a little bit different animal. So again, you have to do your analysis, your hazard risk assessment, look at your lab and see what works best for your situation. Does the FRCP coat repel all liquid? Well, I just kind of went through that. Unfortunately, it doesn't. But keep in mind, if you're wearing your regular poly cotton lab coat, it doesn't protect from any liquid solutions at all. The FRCP coat does repel many solutions. We kind of categorize them as medium to high surface tension, medium to high polarity. If they're splashed on the coat without pressure, then they'll do a good job of repelling. It is air permeable to, give you some breathability, to give it some comfort. And so there's certain nonpolars and liquids under pressure that could penetrate through the fabric. So the trade-off is, if you don't want that to be the case, or if nonpolars are a big issue, then you have to get a non-permeable coat. And the wearability is, not as comfortable for sure. And, again, you've got that decision point where you have to go get that non-permeable one and put it on because you're not going to wear it all day long. So, or you can decide not to wear a coat at all. So it doesn't repel everything, but there's a long list, and that's in one of our technical briefs that we have a whole host of different acids and corrosives and things that it does repel. And again, keep in mind, the current coat you're wearing, the just poly cotton white coat, doesn't repel anything. And so, that's a big step up from where you are today. And you don't have to have that separate garment, the disposable or an apron or something else, that you have that decision point coming into play. So, it doesn't repel everything, but it's head and shoulders above what most people wear today in their applications. I've had this come up a couple times. This is kind of interesting. Could the FRCP fabric be made into a glove? Sounds like a good idea. maybe it could be. But one of the things you got to remember about gloves is dexterity is important. Because this is a woven fabric, it's not a knitted. It's not designed to be a glove fabric. So dexterity could be an issue. The other problem is when you're using a glove, it does flex. And this could allow the openings between the yarns to kind of open up further than normal with just a lab coat that's just hanging on you. And that could allow for some penetration. So if you can imagine if you're, flexing your fingers, into more of a fist or grabbing around something, that's stretching that fabric and opening up the spaces between the yarns, could allow for chemical to get some penetration through there. The repellency properties start to diminish when you get into that kind of situation. Or if there's, some kind of a pressure, if you lean your hand down on something, that's going to push liquid through it as well. So not ideal for a glove. So at this point in time, the answer would basically be no, not a glove fabric, not designed to be in a glove. Does the addition of patches, embroidery affect the coat's ability to repel? Good question. Anytime you stitch through a fabric, it's going to open up some kind of a pathway that liquid could potentially penetrate through. And typically, in most cases, and maybe in all cases, the stitching thread itself is not repellent. So again, it could wick through the thread itself that you use to stitch on the patch or the stitching for the embroidery. The likelihood of an inadvertent splash landing directly in that area is pretty low. The amount of chemical that could actually penetrate through would be minimal, be pretty small. So it's best to locate these. If you're going to sew one on, it's best to put it in some kind of a place in an area not likely to be splashed. And you want to minimize the size and the number of these add-ons. So is it going to allow for some potential penetration? Yes, it would, but very little. How risky that is probably small, depending on where you put it. As an example, if you put it on a upper shoulder area, is that going to be exposed to a splash? We're typically working at a work table or bench, and you drop something in front of you. I don't know that your upper right or left shoulder area is particularly vulnerable to that kind of a splash. So, there's some depends on a little bit. But can be done. I know people do it and not had any issues with it. So you just need to kind of look at it in your situation and determine whether or not that'll fit your needs and whether it would be a problem for your application. Is there a way to know if the repellency is still working? Good question. Other than testing it yourself, which you can do, you can take a small drop of chemical and see what happens. Try that. It's good to keep track of the number of launderings. That's a good best practice, so you know whether you're getting to the that 50 number. We state the 50 industrial laundering max, as I mentioned previously. So performing a simple drop test with one of the chemicals and see if it repels, that will give you an indication if it still has repellency properties. But you do want to make sure, obviously, that if you're doing testing, you want to do it in a safe manner. It's in a controlled environment. But other than testing it yourself, there really isn't a way to determine if the repellency is still working. But it's pretty straightforward. I mean, you can even do it with water and see how water works. Now, water is going to repel better than almost anything. So, is that a good practice? It'll give you some indication. But you could try a specific chemical that you're concerned about and see if that one repels in an area that's not real obvious, off the bottom edge or someplace that you could do a test on it. So a couple of things that I wanted to specifically mention. What are the issues with having a separate protection garment? A lot of people have in the past, they have their standard white lab coat, and if they need something, they'll put on that disposable chemical splash, or they'll put on a splash apron, or they'll put on sleeves, or they'll do whatever kind of thing they need to get the protection. And what's the drawbacks of that? Well, the one I've talked about multiple times is the decision point. You're relying on that person in that situation at that point in time to decide, I better go put on that other piece. I better put on that separate chemical protection piece. You're relying on them to make a good decision. And what we found is they often get unused. And people just don't make the decision to go put it on because they haven't had problems in the past. And that leaves them basically unprotected. The other thing that comes up is, sometimes, particularly the aprons, they can be kind of bulky and uncomfortable, and they don't cover everything. They're only covering the front piece of the wearer. Not to mention the fact that they might not even be FR. Just because it's chemical protected doesn't mean it's flame resistant. So if you've got both hazards, that's a problem. You need to make sure that if you have that flammability problem, if you're working with flammable chemicals, vapors, gases, those kind of things, FR is going to be important, and you need that as the outermost layer. You can't be putting the secondary separate chemical piece on that's not FR. Got to be FR, or you're going to have some issues. So, Ed, those were the questions that had come up so far. What else do we have?
Hey, thanks, Mark. We have a few questions that rolled in already. Just a reminder to our audience, if you'd like to ask a question, please type it into the chat window on the lower right side of your screen and send to all panelists. If your chat window isn't open, you may need to hover your mouse toward the bottom of the screen, and some icons will appear, and you need to select the one that looks kind of like a speech bubble. See, the first question here, actually we have a couple from Thomas, and his first question says, relating to heat stress prevention, what is the clothing adjustment factor for your fabrics? He's referring, I think, to the ACGIH TLV values for thermal stress.
Wow. I hate to say that I'm stumped on the question, but I don't have the answer to that one, unfortunately. I'm sure there is some numbers on that, some THL numbers or something that I could come up with, but I don't have that right off the top of my head or in my ready access. So I'm unfortunately going to have to pass on that one and not be able to answer it. I hate doing that, but I don't want to give you a bad answer. So unfortunately, I'm going to have to do a little research on that and come up with an answer after the presentation's over.
No worries, Mark. You're not the first presenter who has been stumped. It happens from time to time. So, Thomas has another question for you. He asks, will oxygen impregnate this FR fabric if the person's exposed to pure oxygen or another substance that can impregnate fabric?
Well, it's not designed for gases. It's designed for liquid repellency. Will it actually impregnate the fibers? It's probably going to inhibit some. Again, that's one of those kind of, I hate to say it, Thomas, that it's a weird question, but it's a little off from what is the norm that I'm used to, because normally we're talking about liquid. And again, this is another one that could be bounced back off the fabric supplier to see about what oxygen will actually impregnate the fibers. My sense is it probably won't, but without getting some real solid info from the fabric manufacturer, I don't think I'm 0 for 2 so far, Ed. So that's not very good, is it?
We'll bring your percentage up here in a second, Mark, I'm sure. Veronica has a question. She asks, I've heard of FR-rated markers for hard surfaces. Are there markers you recommend for FR garments?
Well, we don't recommend, and if you're talking about, taking like a Sharpie and marking on a garment place, we don't recommend doing that on anything, only because, there is the potential for it to be flammable. I'm not aware of any markers that are specifically designed to be FR, so they don't have the potential to be flammable. So I don't believe there is anything that I've seen before. I don't know what it is you're trying to do with your marker, but yeah, there aren't any that I'm aware of. Doesn't mean there's some out there, but I've never run across any that would be considered FR. And regular markers would not be recommended to use on FR garments.
Okay, thanks, Mark. Next question, what are some guidelines to follow if employees wash their lab coat at home versus having them professionally laundered?
That's a good question. A couple things you want to do with, and this holds true for, FR, FRCP, whatever. You definitely want to wash them separately from your regular laundry. You don't want to mix your FR work clothes, so to speak, with your home wash, your family wash. You want to keep them separate. No chlorine bleach, peroxides, no softeners, starches. You don't want to have any additives on them because they can add or kind of mask. And I think I mentioned this earlier. They can affect the ability of the garment to do its job in terms of flame-resistant properties. Warm water doesn't have to be hot water, and you can, if you have something really soiled, stained badly, you can use hot water. I think it's between 140 and 150 degrees F max wash temperatures. But as I mentioned when we talked about the number of launderings, hotter water is going to affect the repellency properties faster than cooler water. So you don't want to do that, and you don't want to over dry them. Don't dry them bone dry. Just do a normal washing. Separate them. Don't use any of the additives, bleaches, and all those kinds of things. Warm water, and don't over dry. Those would kind of be the basic rules of thumb, guidelines, and a lot of that's stated in the laundry instructions on the garment. So, if ever in doubt, look at all the garments have a laundry instruction tag on them. Read those and follow those carefully.
Okay. Next question. You mentioned that stitching or embroidery can affect the lab coat's ability to repel. If a logo or name tag is ironed on instead, will that allow the coat to maintain its repellency?
Yeah, to iron one on the outside, that shouldn't be an issue. If you need to be aware, if it's not an FR tag, if it's just a regular flammable piece of material that you're going to iron on, that it can ignite and it can burn, and some of that heat can transfer through the FR fabric to the wearer. But if it's small, that's not a huge concern. The FR standards like NFPA 2112 actually recommends any individual tag, name tag, logo, label, those kind of things not be any bigger than 16 square inches. So it does give kind of a guideline on the maximum size. And I believe it's you don't want to have more than a total. You're going to put multiple logos and name tags and things on them. You don't want to have a multiple beyond 40 square inches when you add them all up together. So, it's iron them on shouldn't be a problem. You don't want to get the iron too hot. Again, depending on what the this particular fabric, the Nomex base fabric that the FRCP is made of, is pretty resistant to hot temperatures from iron. Some of the other FR fabrics could be a little more vulnerable. They have some fibers in them that don't have as high a melt temperature as the Nomex, and so you got to be a little more careful. But on the lab coats, it shouldn't be an issue. That should be fine. Again, it's small. You want to be small. You don't want to put tons of heat on them. You just want to get them on, and not too many of them. So that's kind of the basics.
Okay, Mark, we don't have any other questions, but we do have a comment that Carol just shared with the group that I think it would be good to mention here. I'm not sure if you have anything to add, but Carol wrote, bringing a lab coat home to wash is likely to expose anyone along the commute and the home to whatever you are trying to protect the worker from exposure to. Have the company send out to a commercial laundry or launder the lab coats at the site.
Yeah, I would agree with that totally. You gotta understand what your risks are. If you're working around some nasty stuff that you don't want anybody to be around, obviously that's not a good thing to take home. So, you got to use some common sense, have some protocols, guidelines in your lab about what you can and can't do, what stays. One of the other questions that comes up periodically has to do with bloodborne pathogens getting on the coats, and the coat's not designed for that kind of protection. Will it repel some of that? Possibly, but that's a whole different animal, and if you get those kinds of exposures, obviously you don't want that leaving the lab. That's got to be quarantined, that's got to be kept separate, and dealt with some special protocols. Yeah, you got to be smart about it, but Carol's absolutely right. If you've got some bad stuff on it, you don't want to be carrying it around and exposing others, including those at home, to whatever those chemicals, materials, whatever it might be that's on the coat. So that's a good point. Thanks, Carol.
Okay, well, if there aren't any more questions, we'll go ahead and conclude today's webinar. My thanks to Mark Sainer for his presentation, to Bulwark for sponsoring today's webinar, and to all of our participants. If you liked this webinar, please consider joining us at 2 o'clock Eastern Time next Wednesday, November 13th, when Bulwark's Derek Sang will present Why is FRAR Compliance So Difficult? To register for that webinar, visit aiha.webdent.tv.
And Ed, I'd also like to thank everybody for attending, and thank AIHA for allowing us to give this presentation. Hopefully it was beneficial, and there were some few nuggets of good information that people could take from this and apply back in their labs. And we want everybody to be as safe as possible. So if you have other questions you think of later, feel free to contact us, and we'll try and address those as best we can.
I appreciate it. Thanks very much, Mark.